Morning everyone, welcome to another episode of HPC in the Cloud. I'm Joe Schoonover from Fluid Numerics. Bright and sunny day here in Boulder, Colorado, and today we're going to be showing you how to connect your Paraview client to a Paraview server on some auto-scaling compute nodes on Google Cloud. So let's just go ahead and get started. So the first thing you're going to need to do, head on over to console.cloud.google.com. If you do not have an auto-scaling HPC cluster yet, essentially today we're picking up from where we left off last week, where we were running OpenFOAM jobs using the FluidSlurm GCP solution. If you want to just start with us today, head on over to that Products and Services menu, click on Marketplace, and take a search for FluidSlurm GCP. Just use that top solution there, hit launch, and go ahead and fill out this deployment form here. And just the only things to keep in mind is when you're filling this out, make sure that just configure your partition name for today. Just set it to Paraview and set the boot disk size to 50 gigs. Once you do that, go ahead and hit deploy and you should be good to go. Since I've already created one, I'm not going to create another cluster for myself. You can pick up and follow along with us on the next step here. So what we need to do is actually configure a custom firewall rule to allow you to set up a reverse TCP connection we're going to use port 11,000 today, so that we can basically run the Paraview server on some compute nodes that will connect back to the login node. And then from the login node, we want to have that reverse SSH connection back to your local workstation. So what you can do is go to that Products and Services menu, scroll down until you get to the Networking, VPC Network, and go to Firewall. Once you're in the firewall settings there, hit Create Firewall, and let's go ahead and fill this out. So what we're going to do is call this PV Server SSH Tunnel. If you're using default networking, you can leave the network alone. If you're using a non-standard network, go ahead and select that network here. On the targets, we want to basically apply this rule right now to all instances in the network. Really, it should only be applied to the login node, and you would do that by putting a target network tag on that login node. That's not the point of today's exercise, so just go ahead and hit all instances in the network. And then for that source IP range, take a look. If you don't know what your external IP address is for your home institution, just go onto Google and type in what is my IP address. There's plenty of resources. You'll be able to find your IPv4 IP address. Put that in here in the firewall rule settings so that only your office or your colleagues can use this connection. Now down on the specified protocols and port, click that TCP box and set the port number to 11,000. Once you're done there, hit create. Again, I've already created one for myself doing this tutorial yesterday. But that will get you set up so we can set up this reverse TCP connection to connect your Paraview client to Paraview server on the cloud. Okay, so now that that's in place, assuming you do have a cluster, we need to hop onto that cluster to configure the partitions to use a Paraview GCP image that we've prepared for you. I'm going to show you how to do this from the Cloud Console. So up on the top right, there is a button to activate that Cloud Shell. Go ahead and open that up, and we're going to need to log into the controller instance. So go ahead and copy that external IP, and when that Cloud Shell comes up, you can SSH in. Okay, now that we're in that controller, what we want to do is we want to basically create a cluster configuration file that has the current cluster settings in it. To do that, first we're going to run cluster services, so we do need to be root. So you can run cluster services, list all, and dump that output to config.yaml. Now in that config.yaml, what we need to do is, in this case right now, if you remember from last week, we had set this cluster up to have an OpenFOAM partition to run OpenFOAM GCP. Rather than overwriting that partition, I just want to create another one for working with Paraview. So at the top here, I'm going to grab from line 22, at the top of the partitions, that first partitions entry starting with the labels specifier. From 22, we want to copy down to, let's see here, line 43, so it's 21 lines. Let's yank those and paste that below. Now what we want to do is edit the image specifier. We don't want to use OpenFOAM GCP in this one. We want to use Paraview. And I guess I'll say if you're starting with a fresh cluster today, What you could do is in that first partition block is just add the image specifier. and then use this image here as projects fluid cluster ops global images Paraview GCP. Okay. Down here, I'm going to change the name of my compute nodes in this machine block to Paraview USW2C, and the name of the partition I'm also going to change to Paraview. Now the other thing we want to set up while we're in here is the Slurm accounting. Again, last time we had set the Slurm accounts up so that we could only submit to the OpenFOAM partition. Now that we're adding another partition, let's go in that allowed partitions block and add Paraview. Again, if you're starting from scratch today, your Slurm accounts block is probably just an empty bracket. If you do need to create a Slurm accounts block to start from, just use cluster services sample Slurm accounts, and that will give you a block that you can start from and fill out to your liking. Okay, so now that this is set up, we're going to use cluster services to update our partitions. So first, as always, we're going to preview our changes before we make them, just to make sure everything looks okay. And it looks like I spelled something wrong. Yes, I did. Config equals config.yaml. All right, so we got partitions 1 here. So we got a new partition being added. The name of that partition is Paraview. The name of the machines in that partition block right now are Paraview USW2C, and then we've got the Paraview GCP compute node image. That looks good to me, so let's go ahead and run that same command and remove the preview flag. Next up, we're going to just run the same thing except for the Slurm accounts, just to get our Slurm account updated so that we can submit jobs to that Paraview cluster, or at that Paraview partition. All right, so we're going to do that cluster services update instead of partitions this time. Go ahead and add Slurm accounts. Keep that preview flag on the end just to make sure. And again, I'm just misspelling things this morning like crazy. It's Slurm accounts. It's plural. So, all right, what we're doing here is it's adding a new allowed partition to that first Slurm account block. So we're adding Paraview to it. Let's make sure that that partition name is spelled correctly. So if you run sinfo, you'll see now we do have 2 partitions, OpenFOAM and Paraview. So I think we're looking good there. And we'll run the same command, remove the preview flag. Okay, so at this point, your cluster now has the partitions you need. You now have your Slurm accounting configured so that you can submit those jobs. What we need to do next is hop onto the login node and enable gateway ports for SSH, so that basically we can have that complete reverse SSH connection from the compute nodes through the login node back into your local Paraview client. So let's go ahead and hop out of the controller, copy that login node IP address. Whoops, not a Joe at Paraview. Make sure I get that in the clipboard. There we go. Cool. So now we're in the login node. We do need to go root to make this modification. So go ahead and run sudo su and then vim etc ssh sshd config. Now, when you're in this file, go ahead and search for gateway ports that should be commented out right now. Go ahead and uncomment it and change that no to a yes. Once you've done that, you can use systemctl to restart SSHD. That's all we need to do there. Okay, so the next step here, so we've provided you guys a few scripts that are helpful for setting up this Paraview connection. So one of them is a Paraview server connection file that you'll use with your local Paraview client to set up the connection. And then on the cluster, there's also a job submission script that will get executed when you go through that connection process. So what I want to show you real quick, there's a GitHub repo where you can obtain that stuff. If you just go to github.com/fluidnumerics/fluidslurmgcp custom image bakery, I know it's a mouthful. Inside of that repository, there's an examples directory, and inside those examples, you'll find Paraview. In Paraview, there's that submit paraview.sh and the Paraview GCP Paraview server connection file. We're going to need both of those for today's tutorial. So if you don't have them already on your cluster, go ahead and clone that repository. You should have a directory called fluidslurmgcp custom image bakery. What we want to do is move that job submission file to apps share. I mean, you could really put it wherever. It doesn't matter. You'll be able to select that when you go to do the connection. We just like to put it in a nice consistent location for you guys. Okay, so let's make a directory, apps, just in case. apps share. Okay, and let's go ahead and copy Fluid Slurm GCP custom image bakery examples, submit Paraview, whoops, Paraview, submit paraview.sh back to that apps share directory. All right, so that's it there. Now what we got to do is hop onto our local system. So if you open up a terminal on your side, what we're going to do now is SCP down the PVSC file from the cluster and get ourselves started with Paraview. Make that text a little bit bigger. All right, so first thing I'm going to do in my home directory is just make a directory. I'm going to call it Paraview PVSC. Looks like I already have one, so that's okay. And what I want to do now is SCP from my login node. Nope, not Fluid Slurm GCP custom image bakery. I want the login node IP address. So we'll SCP from there, and now we've got the path to that PVSC file. Image bakery, examples, Paraview, and Paraview GCP.pvsc. Where are we going to put that? We're going to put that in that Paraview PVSC directory. Okay. Now we're looking good. Let's go ahead and start the Paraview client, and we'll walk through connecting to the cluster. Okay. So once you're in Paraview, your window may look like this. If you don't have that memory inspector on the right-hand side, you can have that show up if you click on the View menu and you just check the box next to Memory Inspector. I like to keep this open because this will show you that, like right now, you see I only have the client as a compute resource available for doing rendering. Once we connect to the compute server, you'll actually see that show up over here. So in order to connect, go ahead and click the connect icon, which is just below the menu underneath View. There's looks like two servers with a green light between them. Go ahead and click that. And what you're going to do is click on Load Servers and navigate to that wherever you put that PVSC file, and then you'll click on it and click OK. Now, of course, I've already got one open here, but once you've clicked OK, you should see a configuration that looks like this. Now we'll hit Connect. And I'm just going to walk you through very quickly how to fill out this form. The biggest ones to make sure we get right here are the SSH username. That's the username that you have on your cluster, and that login node IP address. So let's go ahead and copy that from the panel. Okay. And remember I said before, we moved that submit paraview.sh to the apps shared directory. I did forget one step here. Back on your login node, we need to make sure that that submit paraview.sh is executable. So if, I'm going to do that real quick. It's ls-l underneath apps share, and okay, we are good. Now if it's not executable already, go ahead and chmod that with 755. So that would be sudo chmod 755 apps share submit paraview.sh. You just want to make sure that that script has those executable bits there for groups and others, since you're not root when you're running this. Okay, anyways. We got our username, we got our IP address in there for the login node. We have the path to that job submission script. Again, if you have it stored somewhere else, just make sure you set that path correctly. The server port. This is going to be the same server port that you used in your firewall rule settings. So today we chose 11,000, so that should be good. The Slurm account. So in your Slurm accounting setup, this is just going to be the name of that Slurm account you use there, and then of course the Slurm partition you're submitting to. Today it's just we're using the CFD Slurm account and Paraview. Then we have the number of processes. So this is the number of MPI ranks that's going to be used to launch the MPI. The number of MPI ranks to launch the Paraview server, and then we have the memory per MPI task and the number of hours to reserve. Once this looks good to you, go ahead and hit OK, and it should open up an Xterm window and keep you updated on the status of that job. So what's actually happening here is when you clicked OK, that Xterm window opened up and executed a few commands on your behalf. Essentially, it ran over SSH it set up a SSH tunnel to your login node over port 11,000, and it also executed the submit paraview.sh script on the login node. So it submitted a job, and now we're just waiting for that node to configure. So on the Google Cloud side, what's actually happening is when that job was submitted, a Paraview node, let's wait for that to refresh here, a Paraview node was created on your behalf. And if I look in the job queue, you can see that job is in a configuring state as well. Now the nice thing is all this is auto scaling, so when we're done and we disconnect from the server, the job will be taken down for you, and then the compute node, after a few minutes of being idle, will also be deleted on your behalf. So you don't have to pay for those idle compute times. All right, so while this is connecting, I kind of want to walk you through what we're going to do on the visualization side here. It says we are continuing from the OpenFOAM demo from last week. If you remember, in the OpenFOAM demonstration, we're running this compressible flow past a NACA 012 airfoil, kind of like what I got shown here on the screen. And the way this is set up is that we have, so flow is going in the X direction, which is going to be left to right here. Whoops, there we go. So we have an inlet flow on the left side of the screen here. Okay, going from left to right at a velocity of u. I believe this is around, on the order of about 100 meters per second in this particular demonstration. And what we want to do is two things. We want to visualize the pressure on the airfoil itself, and what we should expect to see from classic fluid mechanics theory is that we have a high pressure near the leading edge of that airfoil because the flow is slowing down, and Bernoulli's principle says low flow, high pressure. And as we get towards the top of the airfoil, where the flow is the streamlines start to become constricted and the flow speeds up, we should have low pressure on the top and the bottom. Okay, so we want to visualize that pressure, and then what we also want to do is set up some seed points for calculating streamlines in front of the airfoil, and we want those streamlines to basically trace out the flow in the direction of the flow. So, and what we should expect to see is that the flow is diverted around that airfoil, kind of like this. All right. So I'm going to walk you through how we do this in Paraview, and then also to convince you that all this stuff is happening on the cloud in the process, while we're actually using our local Paraview client to do all the rendering. So at this point, our server is now connected. You can see in the memory inspector we now have server over here, and it's listing that Paraview USW2C0 node. And you see we've got those 8 MPI ranks available, and we got we've got quite a bit of memory to work with, which is pretty nice. All right. So what we want to do now is open up some of the files we have from our previous demonstration. So if you remember when we ran that OpenFOAM job last week, we had this airfoil NACA 012 simulation case show up in our home directory. So if I hit open, what's nice now is since I'm connected to the cloud, I can actually access those files up on the cluster. There's that airfoil NACA 012 simulation case. And there should be an empty file in there for you called NACA012.foam. If you don't have one, just go into that directory now on your login node and just run touch NACA012.foam. All right, so I'm going to open this up twice. One of the files I'm going to use for the pressure visualization. The other one I'm going to use for velocity. So in this first one here, let's just do the airfoil mesh, and let's only look at the pressure. And then on this other one here, let's do the internal mesh, and let's only look at the velocity. So the way it's going to work is the pressure is just going to show up on the airfoil, and then the velocity is going to show up in the interior, but we're going to use the velocity to actually calculate streamlines. So let's go ahead and hit apply first, and then we're going to hide the internal mesh view so that we can zoom in on that airfoil. So in that bottom one here, where we're pulling in the velocity and the internal mesh, just go ahead and hide it for now. And let's hide those messages. Let's change the view to the Y perspective, and look at that, it already zoomed in on it for us. So there's our airfoil, and as I was telling you, we do have this high pressure up front, high pressure up front. And we get a low pressure over the ridge of that airfoil, and it gradually gets a little bit higher again as we go towards the tail of that airfoil. Now, of course, it's not the most ideal color map and all that stuff, but not the point today. Okay, so let's go ahead and set up some streamlines. So let's on this bottom data set that we brought in, where we're looking at U and the internal mesh, what we want to do is use the stream tracer filter, which you can find on this row here of some of the quick to access filters here. It looks like a bluff body with some streamlines around it. Go ahead and click on that. Now the length of the domain is 150 meters, but the airfoil itself is actually pretty small. It's about the order of a couple meters long. So let's back this off to about 3. We only want the streamlines to go in the direction of the flow, so let's change that to forward. So the streamlines are traced only in the direction of the flow. And in terms of the location of the seed points, what we want to do is set this up so that they are just in front of the airfoil. So if I remember correctly, this should get us there. Yeah, that's looking all right. Cool. All right. So we got the basically what we're going to do is we're going to set a straight line, and on that line we're going to subdivide it, 20 times, and that'll give us 20 seed points in front of that airfoil. So if I kind of move this around a little bit, you can see we have along this line here, if you were to think about segmenting this evenly at 20 points, those are going to be the locations where the streamlines will start, and then they'll integrate to go basically in the direction of the flow over the airfoil. So that's really it. Once we're here, the only thing we need to do is change that resolution so we're not getting so many dang streamlines, down to 20. And let's go ahead and hit apply. And there we go. We got our flow past an airfoil. So in this case, we're pretty much done with the tutorial today. What I was hoping you'd get out of this is how to connect your client to a Paraview server on the cloud. The last thing here to do is, of course, when you're done with your work, make sure you save everything, and afterwards you can hit that disconnect button. When you hit disconnect, okay, let's go back onto the cloud here. What you'll see, let's refresh that because that node is actually live. What you'll see is now we actually don't have a job in the queue, and that node is now in an idle state. After a few minutes of being idle, that node will be taken down for you. So that's about it for today. I do appreciate you guys joining us. If you like this video, please subscribe to our channel to keep up to date with all the things we got coming your way. A little sneak peek for you, we did just actually submit a solution last night to kind of encapsulate all these configurations for you, so it'll be even easier to run your CFD workflows on Google Cloud. So stay tuned for that. We'll be doing some updates on this tutorial and the OpenFOAM tutorial in the coming weeks. Thanks again for joining.